Good day everyone. Today I will show you how to answer a problem from chapter 6, which will be shown right here. Feel free to pause the video to read the problem. Actually, I'm giving you 10 seconds to read.
Cecilia, you're breaking my heart. You're shaking my confidence daily.
Okay, the solution of the problem will be CV, boiler steady single inlet and exit flow. Neglect kinetic energy, potential energies in flow. We'll be arriving at continuity equation. Mass flow rate state 1 is equal to mass flow rate at state 2 and mass flow rate state 3. This will be the illustration of the problem. This will be the boiler and this represents the superheater. This is the heat transfer rate of the superheater and this is the heat transfer rate of the boiler. In these two graphs shows the changes. So the change in pressure is there's actually no change in the pressure. So the pressure at state 1 and state 2 and state 3 are equal. But the temperature graph shows that at state 1 and state 2 is equal and the state 3 is way higher than the state 2 and 1. Okay, in getting the enthalpy of state 1 and 2 and 3 is getting it from the thermodynamics table. So the enthalpy at state 1 will be negative 82.469 kilojoules per kilogram. That was the enthalpy of saturated liquid at 600 kPa. The enthalpy at state 2 will be 86.85 kilojoules per kilogram. That will be that was get from the enthalpy of saturated vapor at 600 kPa. The enthalpy at state 3 is equal to 289.05 kilojoules per kilogram. That was get from the superheated table of the saturated nitrogen at 600 kPa and 280 kelvins. So the energy equation will be Q boiler is equal to enthalpy at state 2 minus enthalpy at state 1 equals to 86.85 minus 81.469. And that will be equal to 168.32 kilojoules per kilogram. The Q dot of boiler will be the mass flow rate times the Q boiler. That will be equal to 0.005 times 168.32. That will be equal also to 0.8416. So mass the heat transfer rate of the boiler is equal to 0.842 kilowatts. Okay, the CV of superheater will be the same approximations as for the boiler. So using the last equation, the energy equation will be Q of superheater is equal to enthalpy at state 3 minus enthalpy at state 2. That will be equal to 289.05 minus 86.85. That also be equal to 202.2 kilojoules per kilogram. So the heat transfer rate of the superheater will be the mass flow rate times the Q of superheater. That will be 0.005 times 202.2. And Q dot will be 1.011 kilowatts.